Hello guys, so far in the previous lectures we have learned these conversations. If you miss, the link is available in the description. In today's lecture we are going to learn how to convert binary number system into hexadecimal number system, hexadecimal number system into binary number system, octal number system into hexadecimal number system, and hexadecimal number system into octal number system. So let's start the lecture with binary to hexadecimal conversion. The procedure to convert binary number into hexadecimal is similar to binary to octal conversion. The only difference is that here we are making group of 4 bits. Suppose I have to convert 1101 radix 2 into radix 16, that is from binary to hexadecimal. I have made a group of 4 bits from right hand side, so that is 1101. On substituting this in 8421 formula, we have 8 plus 4 12 plus 1 13. 13 is equal to D in hexadecimal. So we have 1101 radix 2 is equal to D in radix 16. Now why 4 bits? As we know that the hexadecimal number system consists of 16 numbers and the maximum value is F, that is 15. To write 15 in binary, we need 4 bits, that is 8 plus 4 12, 12 plus 2 14, 14 plus 1 15. That's why we are making group of 4 bits. Now let's move to the next example. If I want to convert 1110 radix 2 into radix 16, first I will write the binary bits as it is, then from right to left I will make group of 4 bits. Here I go. As in the last group there are only 3 bits, so I will add 1 0 as we used to add in octal number system. So we have 0 1 1 1, that is when substituting this in 8421 formula, we have 4 plus 2 6 plus 1 7, so we have 7 7. So we can say that 1110 radix 2 is equal to 7 7 radix 16. Let's see one more example. If I want to convert 101101.11011 radix 2 into radix 16, first I will write the binary bits as it is, then from decimal point on the left hand side I will make group of 4 bits from right to left. As in the last group there are only 2 bits, so I will add 2 zeros. And after decimal we are making group of 4 bits from left to right. As in the last group there is only 1 0, so we will add only 1 bit, so we will add 3 zeros. So we have 4 groups. On substituting these values into 8421 formula, we have 0010 0010, that is equal to 2, 1101 that is equal to 13, and 1101 that is equal to 13, and 1000 that is equal to 8. As we know that 13 is equal to D in hexadecimal, so we have 101101.11011 radix 2 is equal to 2D.D8 radix 16. Let's see one more example. If I want to convert 1111.1011101 radix 2 into radix 16, first I will write all the bits as it is, then from decimal point on the left hand side I will make group of 4 bit from right to left. Here we go. In the last group there is only 3 bits, so we will add 1 0. Now on the right hand side of the decimal we will make group of 4 bit from left to right. As in the last bit there is only 3 bits, so we will add 1 0. So we have 0 1 1 0, that is equal to 6, 1111 that is equal to 15, 1011 that is equal to 11 and 1010 that is equal to 10 as it is mentioned here. Now 15 is equal to F, 11 is equal to B and 10 is equal to A in hexadecimal. So we have 11011.101101 radix 2 is equal to 6F point BA radix 16. Here are some practice questions. Now let's move to the next topic, hexadecimal to binary conversion. To convert a hexadecimal number into binary, the procedure is as similar to the octal to binary. The difference is that here we will write a binary code of 4 bit instead of 3 bit. So here we go. 7 is written in 4 bit, that is 0 1 1 1. D that is equal to 13, that is, so 13 can be written as 1101 in binary. So we have 7D radix 16 is equal to 0 111 1101 radix 2. Now as we know that we can remove this leftmost 0, so we can say that 7D radix 16 is equal to 1111 radix 2. Now let's see one more example. If I want to convert 63.BA radix 16 into radix 2, first I will write all the bits and then equivalent binary for each bit in 4 bit form. So 6 can be written as 0110, 3 can be written as 0011, B that is equal to 11 can be written as 1011 and A that is equal to 10 can be written as 1010. Now so we can say that 63.BA radix 16 is equal to 0 11 00011.10111010. As we know that we can remove the leftmost and rightmost zeros, so we have 110010.101101 radix 2. Let's see one more example. Suppose if I want to convert AB.EF radix 16 into radix 2, first I will write 4 bit equivalent binary number for each hexadecimal bit. So we have A that is equal to 10, 10 can be written as 1010, B that is equal to 11 can be written as 1011, E that is equal to 14 can be written as 1110 and F that is equal to 15 can be written as 1111. So AB.EF radix 16 is equal to 101011.11101111 radix 2. Here are some practice questions. Now let's move to the next topic, octal to hexadecimal conversion. To convert an octal number into hexadecimal, there is no direct method and hence we are first converting an octal number into binary number and then that binary number is converted into hexadecimal number. So let's see one example, 73.62 radix 8 which we have to convert in radix 16. So first we will convert 73.628 radix 8 into radix 2. So 7 3 6 2. For each octal digit we will write a 3 bit binary number, that is 7 is written as 111, 3 011, 6 110 and 2 010. Now so we have 73.62 radix 8 is equal to 111011.110010 radix 2. Now this binary number is converted into hexadecimal number. So we have written the numbers, so the binary number as it is 111011.110010. Now we are making group of 4 bits from either side of the decimal point. As in the last group there are only 2 bits, so we will add 2 zeros here as well. As in the last group there are only 2 bits, so we will add 2 zeros. So we have 0011 that is equal to 3, 1011 that is equal to 11, in hexadecimal we will say B, 1100 that is equal to 12, that is C, and 1000 is equal to 8. So we have 73.62 radix 8 is equal to 3B.C8 radix 16. Let's see one more example. Suppose I want to convert 732.651 radix 8 into radix 16. So first I will write 3-bit binary number for each octal digit. So 7 can be written as 111, 3 can be written as 011, 2 can be written as 010, 6 can be written as 110, 5 can be written as 101, and 1 can be written as 001. Now once this octal number is converted into binary, we will convert this binary number into hexadecimal number by making group of 4 bits. So here we go, the first group, the second group, and the third group. In the third group there is only 1 bit, so we will add 3 zeros. Here as well. In the third group there is only 1 bit, so we will add 3 zeros. So we have 0001 that is equal to 1, 1101 that is equal to 13 in hexadecimal, that is D. 1010 is equal to 10 in hexadecimal, it is A. 1101 that is equal to 13 in hexadecimal, it is written as D. Now 0100 that is 4 and 1000 that is 8. So we have 732.651 radix 8 is equal to 1DA.D48 radix 16. Here are some practice questions. Now let's move to the next topic, hexadecimal to octal conversion. To convert a hexadecimal number into octal, there is no direct method, and hence here as well we are first converting the hexadecimal number into binary, and then that binary number is easily converted into octal number system. Here is an example, A2.38 3B radix 16, which has to be converted in radix 8. So first we will convert the hexadecimal number into binary. So A, that is equal to 10, can be written in binary as 1010, 2 can be written as 0010, 3 0011, and B, that is equal to 11, can be written as 1011. So we have A2.3B radix 16 is equal to 101 00010.00111011 radix 2. Now this binary number is then again converted into octal number by making group of 3 bits from either side of the decimal. So first group, second group, and third group. As we know that in the third group there is only 2 bits, so we will add one more 0 here as well. First group, second group, and in the third group there are only 2 bits, so we will add 1 0. So we have 010 that is 2, 100 that is 4, 010 that is 2, 001 that is 1, 110 that is 6, and 110 that is 6. So we have A2.3B radix 16 is equal to 242.166 radix 8. Let's see one more example. If I want to convert AB.CD radix 16 into radix 8, first I will convert each hexadecimal number into binary equivalent binary in 4-bit form, and then that binary is converted into octal by making group of 3 bits. So here we go. A, that is equal to 10, can be written as 1010. B, that is equal to 11, can be written as 1011. C, that is equal to 12, can be written as 1100, and D, that is equal to 13, can be written as 1101. So we have AB.CD radix 16 is equal to 10101011.11001101 radix 2. Now this binary number is converted into octal by making group of 3 bits. So here we go, first group, second group, and in third group there are only 2 bits, so we will add 1 0 here as well. First group, second group, and third group. As in the third group there are only 2 bits, so we will add 1 0. Now 010 is equal to 2, 101 is equal to 5, 011 is equal to 3, 110 is equal to 6, 011 is equal to 3, and 010 is equal to 2. So we have AB.CD radix 16 is equal to 253.632 radix 16. Here are some practice questions. That's all about the number systems In the next lecture, we will start binary arithmetic. Thank you.